Hello, STEM students. Hello mga dear. So, part 2 na tayo ng electric field. Siguro na-shock kayo. Maraming masyadong term last time. Now naman, we're going to proceed to the mathematical part, no? Last time, na-discuss na natin yung electric field definition and descriptions as well as the necessary equations that we need. So we're going to proceed with electric field sample problems which involves one source charge only. So laging ganun, no? Katulad ng electrostatic force or Coulomb's law. Pwedeng um, dalawa lang para mas simple, tapos pwedeng tatlo, and so on to make it more complicated. So dito naman, pag 1, simple computations lang yon, no need for vector addition. Pero kapag 2 or 3 point charges na siya, dun na papasok yung vector addition natin, no? Kasi vector nga ang electric field or electric field strength. Okay? Pero sa part 3 pa yon. Dito lang tayo muna sa part number 2. Let's have sample problem number 1, which is from the module uploaded in your Canvas. According to this, Esmeralda pulls her wool sweater over her head, which charges her body as the sweater rubs against her cotton shirt. What is the electric field at a location where a 1.60 times 10 raised to negative 19 coulomb piece of lint experiences a force of a 3.20 times 10 raised to negative 9 Newton as it floats near Esmeralda, no? So, lint lang yan, pero parang alikabok lang yan, o kaya himulmul lang yan, pero may charge emerald dyan, no? So, here, balik tayo sa Gresa kasi simple nga lang to. Hindi mo kailangan ng sketch at hindi mo kailangan ng free body diagram. So for the given, we have the test charge, which is 1.60 times 10 raised to negative 19 coulomb. So bakit ko nasabi that this is test charge and not point charge, no? Ayan. First, yung sweater, tsaka yung body ni Esmeralda, yung anong tawag dyan? Yung na-charge. Tapos, as a result, syempre na-charge din yung lint as it is rubbed in her body. Tsaka mas maliit siya. Ito po yung keyword mo, no? Sabi, a piece of lint experiences a force. It's the one that experiences the force. So test charge is the one that experiences the force due to the electric field emitted by the point charge. So, ang taga-exert ng force palagi is yung bigger charge. Kaya, masasabi natin that this is a test charge kahit hindi siya sabihin sa problem. So, katingnan mo yung magnitude niya, no? Times 10 raised to negative 19. Halos kapantay lang ng sa elementary charge. Okay? And then the force, electrostatic force, is 3.20 times 10 raised to negative 9 Newton. Okay, so we have to find the electric field, and then the equation for that is simply E is equal to F sub E over Q naught. And then we just have to substitute the given on the equation for the solution, and then the answer is 2 times 10 raised to 10 Newton per coulomb. Ganun lang siya kadali. No? Sample problem number 1. Now let's proceed to sample problem number 2, which can be found in on page 24 of your textbook. No? Sabi dito, find the force on an electron if it is placed at a point where the electric field intensity is 240 Newton per coulomb directed to the right. Tingnan nyo, no? Katulad ng sinabi ko, yung ginamit ko sa PowerPoint presentation for part 1 is electric field strength. In your book, the term used is electric field intensity, and they are synonymous to each other. Sometimes it is just said as or stated as electric field, walang intensity or strength, and they are all synonymous to each other, no? Ayan. So the given are the following. We have the test charge in the form of electron, and we know that the magnitude of the charge of an electron is equal to the elementary charge. Okay? So, kaya ko hinighlight dyan yung electron kasi there are times that the problem will only tell you that the test charge is either a proton or an electron. Hindi niyo sasabihin sa'yo yung charge. You should remember that the charge of a proton as well as the charge of an electron is equal to the elementary charge. Okay? That's 1.602 times 10 raised to negative 19 coulomb. Magnitude lang naman kinukuha dyan, so kahit wala ng negative, pero nilagay ko lang to emphasize that it is an electron. And then the electric field strength or intensity is 240 Newton per coulomb. Okay? And then we are looking for the electrostatic force. And to get that, we just have to multiply the electric field strength by the magnitude of the test charge. Okay? Ayan. So for the solution, we just substitute and then we get 3.84 times 10 raised to negative 17 newtons to the left. Hala ma'am, saan nanggaling yan to the left? Okay? To the left, to the left. Tingnan natin kung saan yan nanggaling. Look at the problem. Sabi dito, the electric field intensity is directed to the right. Usually, dun sa kasi sa sample problem number 1 natin, no, anong tawag dyan? No directions involved. Diba? Wala siyang binanggit na direction. Although, pwede mo namang ilagay, ano ko lang, no? Balik ko lang dito. Pwede mong ilagay na, anong tawag doon? Wala siyang sinabi pala kung anong direction ng force, diba? Ayan, as it floats near Esmeralda lang. So, hindi na natin lalagyan ng direction yung electric field. Pero usually, kung ano, hindi. Pero as a rule, kung ano yung direction ng force, yun yung direction ng electric field and vice versa. If the test charge is positive. Again, whatever is the direction stated for the electric field will be the same as the direction of the electrostatic force if the test charge is positive. Katulad dito, positive siya. So kung naglagay ng direction dito, yung problem, magkakaroon ng same direction si electric field. Kaso dito sa ating problem, notice that our test charge is negative. Okay, ayan. So, paano kapag negative yung test charge, no? If the test charge is negative, the direction of electric field is opposite to the direction of the electrostatic force and vice versa. Again, kapag positive, they are going in the same direction, the electric field and then the electrostatic force. On the other hand, if the test charge is negative, the electrostatic force is in the opposite direction as the electric field and vice versa. No? So, kaya dito, si electric field, papunta siyang right, si electrostatic force, papuntang left because our test charge is an electron and electrons are negatively charged. Okay? Next. So, kapag sa problem, may nabanggit na direction, yung final answer mo kapag either electrostatic force or electric field, dapat may direction din siya. No? Let's have sample problem number 3. Calculate the magnitude and direction of the electric field 0.45 meters from a positive 7.85 times 10 raised to negative 9 coulomb point charge. So again, katulad ng sinabi ko, source charges are also known as, point charges. So ito yung given natin. Capital letter Q is positive 7.85 times 10 raised to negative 9 coulomb, and then the R, and then the K, huwag kakalimutan. So ito dito, kanina kung mapapansin nyo, yung mga binibigay is either electrostatic force, electric field, saka test charge. But this time, we are given with the point charge or the source charge. So gagamitin natin yung pangalawang equation for electric field. Okay? Ayan, we are looking for the electric field and then we're going to use this one. Yung merong Coulomb's constant, merong separation distance, at saka merong positive, ay mayroong point charge. Notice na dito, wala siyang binanggit na test charge whatsoever na nandun sa electric field. Kasi nga, pwede na kahit at a certain point, merong electric field kahit walang test charge doon. So ito yung example na yon. At 0.5 meters away from the point charge, there exists an electric field even if there is no test charge that experiences it. So pwede ka rin maglagay doon ng test charge para malaman mo yung strength niya, pero kahit wala yung test charge, malalaman mo pa rin na may electric field doon, no? Ayan. So let's just substitute everything to the equation and we are going to have the answer 348.89 Newton per Coulomb away from the point charge. Ngayon, dito, pwede na nating malaman yung direksyon kahit hindi natin alam yung direction ng force. Hindi naman factor yung force doon sa equation natin. So, paano ko nasabi that the electric field is away from the point charge? Because, as a rule, katulad ng sinabi dun sa rules in electric field lines at saka dun sa electric field lines of isolated point or source charges, kapag positive yung point charge, the direction of the electric field is away from the point charge. So generally, pwede mong masabi whether the electric field is going away from the charge or going towards the charge. So that could also be a description of direction. So kapag ganito yung problem, tapos alam mo yung sign ng ating point charge, you can include in your final answer the direction, which is either away or towards. If the point charge is positive, you have to write away from the point charge. If the point charge is negative, you can write or you will write towards the point charge. Now let's have sample problem number 4, which is from University Physics, 14th edition, Global Edition 2016 by Young and Friedman. Okay, ayan. Sabi dito, a particle has charge, negative 3.35 nanocoulomb. Letter A, find the magnitude and direction of the electric field due to this particle at a point 0.2 meters directly above it. At what distance from this particle does its electric field have a magnitude of 11.2 Newton per Coulomb? No? Ayan. So, first, let's have the given. Meron tayong charge. Particle has a charge of this. So, paano ko siya na-determine as the point charge or source charge? Because of the nano. So, malaking charge ito times 10 raised to negative 9, no? And then notice, meron akong E sub B at saka R sub A, no? Kasi sa letter A, hahanapin mo yung magnitude and direction of the electric field due to this particle, ayan, naglagay pa ng direction pala, no? At a point 0.20 meters directly above it. No? So, kung i-drawing natin, although hindi naman kailangan, nasa taas daw yung point, tapos nasa baba yung ating charge na negative 3.35. Okay? So, sa letter A, ang hinahanap natin ay electric field. Pero, kailangan natin ng distance. R sub A. Okay? Ayan. Sa letter B naman, ang hinahanap is distance. At kailangan natin ng electric field for that. Kaya naglagay ako ng E sub B. Ito yung electric field na gagamitin sa B kasi binigay niya yun, no? So, hindi mo gagamitin yung makukompute mo sa A para sa letter B. Magkaiba sila. Okay? Kaya naglagay na lang ako ng subscript para mapag-iba ko sila, no? Para sa letter A tsaka para sa letter B. Again, letter A, ang hahanapin mo is electric field. Para makuha mo yan, kailangan mo ng separation distance R sub A. Sa number 2 naman, ang hinahanap natin ay separation distance when the electric field has a value like this. Okay? Kaya meron tayong E sub B, which is the electric field for finding what is missing in letter B. For the equation, E sub A will be KQ over RA squared. Notice, parehong charge lang naman yung nag-a-act sa parehong situation. Magkaiba lang yung electric fields. Paano nagkaiba yun, ma'am, yung electric field strength? Kasi magkaiba sila ng distance from the point charge, okay? And then for the R sub B naman, we have square root of K Q over EB. Saan naman yan nanggaling, no? Let me just derive to you the equation, no? Ayan, dito sa orange part. Wait lang, parang hindi yata appropriate na red yung gagamitin ko. Gawin natin kulay black. Ay, ayan. So, galing yan dun sa E. EB, syempre. Okay. Is equal to K Q over R squared. Okay, so we cross multiply and it will become R squared equal to K absolute value Q all over E sub B. Tapos pag nakakita ka ng square dito, dapat extract mo yung root niya, no? So you square root and then R will be just, R squared will be R, and then this one we will copy here. That's why ito yung result naman. Okay? Ayan. So, balik tayo sa color red na pen. And let's proceed to the solution number 1. Yan, sinubstitute ko lang. And then we get 753.75 Newton per coulomb. Tapos ang direction niya, kung nasa taas, would be downward. Hala, bakit ganun, ma'am? Bakit downward? No? Kasi negative ang ating point charge. So kung ito yung negative point charge mo, tapos nandito daw yung point, 0.2 meters, the electric field would be going towards. Okay? Towards. So pababa, relative dun sa point na ating tinutukoy. Okay? Ayan. So, downward siya kapag negative. Paano kapag positive naman yan? Upward naman siya kasi nasa, anong tawag dito? Above. Okay? So, paano kung yung problem naman, ma'am? Below. Below yung point. Ayan. So, kung below yung point naman natin, below the charge, no, yung direction ay magiging upward pag negative. Pag positive naman, downward. Okay? Pag ganyan na positive. Okay? Ayan. Hopefully na-note natin yun, no, mga kabataan. And then for RB, we substitute again, and then the answer is 1.64 meters. So again, those two, although the charge is equal, pareho naman 3.35 nanocoulomb, dahil magkaiba sila ng distance, or yung points natin ay magkaiba ng distance from our charge or from our source charge, magkaiba din yung electric field strength na na-experience nila. Sa letter A, ito yung value. Tapos sa letter B, B given naman siya. Tapos yung distance dito sa EA, 0.2. Pero sa letter B, 1.64. Okay? Okay. Thank you for listening to part 2 of electric fields, and see you again to part 3 of electric fields discussion. Bye-bye.